All right. All right, folks, we are live and we're going to take off here. Lost the camera, Johan. Yep. Are we good to go? Okay, perfect. All right. Well, welcome, folks, to another live. There he goes, Johan. Live stream here. This is Shawn Willsey, geology professor, and I'm sitting in my office in Idaho on a snowy morning operating this drone remotely in Iceland, thanks to the good folks at Nature Eye. You can go to natureeye.com to read about how you can do this on your own. Um, but we're going to fly back over the eruptive site from December 18th, and looks like we have good weather. You can just start to make out the power plant there on the left with those plumes of steam coming out. And you can also see the lava field just ahead of us here. And so we're going to fly over the lava field here, kind of find out, see what we can. Of course, this is the place where we might be seeing a new eruption take place anytime. It would be super exciting if it happened during our 30-minute flight, but pretty low chance of that. But nonetheless, we'll see how this goes. Um, and I'm running the drone, so you guys are just buckle up and just be ready for anything here. So we're heading to the west, northwest, I suppose, and we'll be able to look at. You can still see some of the steam and gases coming off of this lava field, and it takes a good, several years, depending on how thick the flows are, for these things to completely cool and solidify. We still have. It looks quite similar to the 2021 to 2023 flows over Fagradalsfjall to the east. They look very similar to this, but this is, just to give it some context and to make it exciting, even though it's already pretty exciting. This is the same uh, place that erupted December 18th, and this is possibly one of the newest patches of ground on Earth. You're looking at rock that is only and new land that is only what, maybe 3 weeks old, which is pretty remarkable. So we'll head out over here. We can get some photos as we go. The controls are pretty easy to use. It's just, forward, left, right, back, and then some swivel controls to operate the camera. But there's the edge of the flow field on the eastern side. And we should be able, if we're going to swing around a little bit this way here and head towards that main eruptive crater. If you remember, as this eruption was winding down, there was a southern vent and a northern vent that were operating. Um, the longest, and this is the northern one here. Fun little fact that Johan, the pilot, told me about just before we launched is that this area here, this Sinnuxgiga region, this old crater row, used to be a place for sheep thieves. They would hide in here in the little nooks and crannies in the terrain. This was their kind of hideout region. Was this part of Iceland, which is kind of interesting. So we'll go down a little bit lower here. We can use some of the camera features as we get closer. Um, let's start over here at the crater. And then the big hill in the background there, that's, I believe that's Selingerfeld, one of the older volcanoes that erupted underneath the glacier. A lot of the subglacial volcanoes are pretty obvious because they're the prominent topographic features that stick up from the landscape. So if this looks like something that would be cool to do, and it is really fun, this is something you can sign up for. You can go to natureeye.com. If you put in my first name, Shawn, SHAWN, and buy a gift certificate using that code, you can book a flight here in Iceland or elsewhere. They have some other localities as well. And you can fly around and take pictures like we are here. Let's get a picture right there. So just tapping the space bar takes a picture, and then these all get uploaded. So it's just a really cool piece of technology. Just when they came to me and said, "Hey, we can offer this to you," it was pretty incredible to think that this was something that we could actually pursue together. So let's head a little bit further. You can see there's several sort of hotspots, I suppose, or regions on the lava field where it's still degassing. The gas is escaping through conduits and fractures in the lava and coming up towards the surface. Let's go ahead and kind of look down a little bit more. What's also fun to do here is you can also sometimes see a couple things here. The texture of the lava indicates a little bit how it was flowing as it was cooling and solidifying. There's places here where you can see it's quite smooth, um, and other places where it's more broken up. And the broken up places would be where we have uh, crusts of lava that are buckling as there's still movement and stress from beneath. Let's swing around here and get a little bit more of a panoramic view. So now we're looking a little more to the southwest, towards the edge of the flow, and we might be able to just make out. Let's see, we got to swing around this way a little bit more. There's some places we can't quite get to because we need some line of sight uh, for the drone and the control. So we need to make sure we're not ducking in behind some of these mountains too far. But there you go. There's just like a beautiful patch of baby Earth that's cooling and solidifying right before your eyes. I need to swing around a little bit more this way, and then we might be able to get a little bit of a look back to the south. They are working on putting up the berm or the wall. So now we're looking towards the north. Might be able to use some of the camera features here to zoom in a bit. So if we put in the zoom, we can zoom in on this little patch here maybe. And then oh, okay. Great. So yeah, we got a little area here that's degassing. Um, and then some of the discoloration you see on the flow field is from some of the sulfuric gases. Places it might be yellow, and other places it might be a little bit different color. So we'll head a little bit more this way. Maybe drop down just a little bit. Just really fun opportunity. Um, you can see all the lava spatter that had piled up right here. Um, and then a lot of the flow, once that lava fell out of the sky as it was fountaining this material, it actually preferentially flowed mainly to the east. So there's a lot more lava field off to the east than there is to the west. Let's look down kind of below us here and see what we can see. And this area could be steaming, I suppose, or degassing for, again, like I said, just several years. Swinging around to the east now, and then try to take a look down here to the south end of the flow field, and might just be able to make out Grindavik down here into the distance. So let's see if we can maybe zoom in on that a bit. Yeah, so you can see the town out there in the distance. Get it kind of recentered here. Yeah, and the zoom's pretty nice. So now you're starting to see some of the buildings. You can actually see some of the individual. I mean, you can even see the waves breaking out there in the distance. And I'm not quite sure, but it does look like to me like just this side of the building, there's a bit of an embankment. So I'm feel pretty confident that could be part of the berm or the wall, the structural barrier that they're working on to um, prevent lava, hopefully, from entering the town if it were to erupt again. So you might be able to make that out there, just on the left side, just left of that hill, and just beyond the flow field between the lava here and those buildings out there in the distance. So um, yeah, so let's go look around on the lava field a little more and see what we can find. There may be a few, although I would think at this point there may not be a lot of incandescent spots, places in the flow field that are glowing, even though there's probably still incandescent lava in the subsurface. Not sure. Okay, thanks, Johan. Yeah, it helped. Yep, there we go. Okay, so yeah, Johan was just telling me I needed to drop down a little bit there. There's a helicopter in the sky, and he was also giving me some tips on um, using the zoom. So the nice thing about doing this is you do have someone who's got your back. You're not going to crash the drone into a mountainside or something like that. He can take over if things get kind of squirrely for me or if anything goes awry. Okay, we'll kind of go up here and head this way a little bit. Oh, you can see the helicopter right there, just over the hill. Yeah. Yep, I saw it. From 2021, Johan. I think we'll just stay here if that's okay. Okay. No, yeah, that's good. Hoping I'm gonna see if we can zoom in on some of these little spots here and see if we can see. Oh, that's great there. So you can see the buckled crust. It looks like just slabs of asphalt, and then you can see these white mineralized areas around some of the vents, um, where it's just degassing, and so you have all these gases trapped in this lava, and a lot of that escaped as it reached the surface, but a lot of it's still trapped. And so as this cools and solidifies over the next few years, you're likely to see more places like this. And this landscape will ultimately be, this black lava, but also with these discoloration zones in there. So let's see. I'm going to swing around this way, head back to the north a little bit. Let's bring the camera up a little. Yeah, so it's as simple as just pushing a few buttons, team. It takes a little getting used to, but if I can do it, anyone can do it. That's for sure. Maybe get a nice picture there. So yeah, just tapping the space bar takes photos for you. You drop down a little bit here. Pretty awesome. Well, I mean, sometimes for me, the any sort of either eruption or a scene like this, which is just post eruption, um, is, I mean, in a way, it's almost to me like a bit. I don't want to be too cheesy with it, but it's kind of spiritual in a way. I mean, this is exactly how gives me goosebumps thinking about how this is how the primordial Earth looked, billions of years ago. If you could go back in time and look at our planet, this is what you would have seen early in its history. Just a lava ocean that was cooling and solidifying, and out of this came, eventually continents and life evolving. Pretty remarkable. Let's see if we can see anything. This is this little sort of half horseshoe shaped crater, um, that was partly there prior to the eruption, and then the vent sort of occupied part of this crater there. So we can see some of the gases coming out of these fractures here, these vents. Zoom back out just a little bit here. Oh, there we go. And let's maybe go, we can get right over this thing and then maybe look straight down, see if that works. And that looks like that could be the vent right there, which was next to this horseshoe crater. You can see this sort of circular depression right in front of us. That very likely was part of that northern vent when it was erupting. Okay, yeah, and Johan just confirmed to me, yeah, that's the northern vent right there that we're looking at. So maybe take a photo of that. Um, Interestingly, you don't see a lot of gas coming out of that actual vent. It seems to be concentrated just to the south and to the north. But the degassing is just going to take place where the fractures are, where there's more porosity, where there's more pore space, in where the fractures are interconnected, and the gases have a pathway to escape to the surface. So maybe kind of look at this little spot here. Yeah, and we'll go a little bit further, and then we'll need to head back soon. The batteries only last so long, but these big cracks you can see in the surface, pretty impressive as this flow was advancing. Let's see. Yeah, so let's swing around to around this north end, and we'll start looking back to the south here. Make sure the camera. Sometimes if you got the camera zoomed in, and you're trying to move it around, it can sometimes pixelate a little bit. Okay, great. Right. So temperatures on this thing could still be, um, where the places where it's degassing, the surface temperature is probably mostly cool to the touch if you actually were to, put your hand on parts of it. Obviously, where the gases are coming out, things are a little bit hotter. Um, but internally, you probably have temperatures, probably still maybe 1,000 degrees Celsius, so still pretty hot. Um, and remember that in the scale of eruptions, this is a fairly small eruption. And we've seen much bigger eruptions than this, not just in Iceland, but in other places as well. So we'll swing around this way a little bit and maybe start moving kind of back along this edge of the flow field. So, and we might be getting to the critical time when the drone needs to head back. And usually when we get there, Johan takes over, and you can always tell when he takes over because the cinematography gets infinitely better. but a nice view there of the eastern edge of the flow field. Okay. And looks like Johan's at the controls now. He's going to take us home, so he'll probably give us a nice view coming back in. So yeah, again, just appreciate the good folks at Nature Eye. You can go to natureeye.com if you want to do this on your own, or maybe there's someone you know that would appreciate it, as a gift, or just letting them know that this is a possibility, that they can remotely operate a drone, take photos um, from some remote location. Pretty easy to do, pretty easy to book. So we'll let him take the drone back. I'll maybe point out a few things as we go, and then when we get the drone back safely home, we'll switch over to me, and we'll do some Q&A, and we can go through the live chat and see what questions you good folks have. I have a few things prepared in way of an update for today. There's not a whole lot going on, but we can look at the earthquake data and GPS data and then answer a few questions. I also have a couple things I've prepared, maybe diving back into some of the topics I talked about in yesterday's update in regards to those earthquakes that happened in the Krishevik region to the east. And so we'll tackle a few of those things. The view there, Johan's got a nice view there. You might be able to pick out, yeah, right near the center of the view, that kind of hat-shaped ridge. That's the eruptive vent from the 2021 Fagradalsfjall eruption. So that was the eruptive cone, the spatter cone that emitted most of the lava during that eruption. So we're very close to these last three eruptions in the Reykjanes Peninsula. They're just off in that direction there to the east or northeast. So nice little view of that cone there. And if you were to head over that ridge, and we did this on the December 18th, we did a flight in the same region, but of course it hadn't erupted then, and we flew back over there and looked at some of the 2021 flows. Um, and they looked a lot like what you saw there, with just this black landscape and lots of steam being emitted. Pretty impressive. So that's a fresh eruptive cone right there, just a couple of years old. And that's a good view to the east. And now we're swinging back to the south, looking towards the coast and kind of heading into the car park where we took off from. So pretty awesome opportunity. So again, I'm sure Nature Eye will use them again if we get an eruption, if we can. It all depends on access and what we're able to get to, and making sure we're following local and regional rules and policies, procedures. It's an evolving sort of situation there in Iceland for sure. But we'll continue to do these on occasion, especially once we get, if there's an eruption that takes place. That's where this thing really becomes a super valuable tool. But even looking at this flow field was pretty impressive, and even just going over any interesting geologic landscape, you can fly this drone around, take pictures, and I think we all know seeing things from the air and having that scale is really valuable, and gives context and a perspective that we sometimes don't get just from the ground. So, well, with that, I'm going to go ahead and sign off from the drone part of our little presentation, and we will then go to the Q&A. So thanks again to the good folks at Nature Eye. Thank you, Johan, for your help. One last little look there as he's zooming along close to the ground. Okay, so we're back to me. So let's go ahead and let me go through and find maybe a couple of questions first, and then we can, let's see, are we able to share my screen? If I can share my screen, that would be good. Graham, if you're there, can you enable my screen share?
So, hey, Sean. I'm actually not quite sure how to do that.
Oh, okay.
I'll try and figure it out. But
Well, it was
maybe
on before. It was just when it was just sharing
okay.
the drone view.
I'll
So
give it a shot now. Hold on a sec.
okay, yeah, there we go. Perfect. Thanks, Graham. All right, so let me go through a couple things here as we kind of go into part two of this presentation and share just a few things with you. Just a quick update for today. Again, it's the 4th of January. As we look at the earthquake data over the past um, 24 hours, you can see just, nothing around north of Grindavik. There's, I think, maybe one earthquake, a 0.3 magnitude quake in the last 24 hours. So it's gone eerily silent in this area. And that's, not out of that's somewhat normal, I suppose. We already have magma in the subsurface. We've thermally heated and weakened the crust in this region. The magma has inflated, and we're only going to see earthquakes if the magma pushes into some new region and starts breaking rocks. We're only going to see that magma um, creating earthquakes if it's moving into new regions that it hasn't occupied previously, or if it's moving upwards. And so that's not totally um, strange, but 24 hours with one tiny quake in that region is a little bit lower than what we've seen, but not out of the question. And then, of course, there was the swarm of quakes off to the east in the Krishevik system. And so you can see over the last 24 hours, a few of those, 1.5, 1.7, that might be the biggest one in the series there. And these are likely just aftershocks, right? So these we believe are these tectonic quakes, or quakes that were generated by the changing stress regime in the area. And I actually want to spend a little bit more time discussing that, um, because I think, and we can also look at this view here too. This is just a different view with a different map, but this shows if we go last 24 hours, um, again, nothing really much here near Grindavik, and then the swarm over here. If you zoom in, you can see some of those. There's that 2.0, 1.7. And so I talked about this a little bit yesterday in the update. So you might be asking, well, what does that mean when I say, well, the stresses have changed, or the stress regime? So remember, lots of things have changed in this area over the last, well, certainly 3 or 4 years, but even in the last few months as well. And so we've got different factors that play into the stress that rocks experience in any given region. So the first one, of course, is plate tectonics, right? The regional stress field generated by the movement of the plates in the area. And of course, in this area of Iceland, we have a divergent plate boundary. The extension is more or less not perfectly east-west; it's more northwest-southeast. So there's that stress, but that stress is sort of a constant in terms of it's always sort of present and in the background. Other stresses that we have might be things like geothermal fluid. So we know we have this power plant here and the Blue Lagoon. So we have a hot groundwater system nearby, and that can exert some pore pressure on the rocks as well, as that groundwater moves through fractures, and that water is very hot materials expand. And so that exerts some stress on the rocks as well. Probably a minor player, but still worth pointing out. Um, and then if we look at maybe a third thing, we just had this eruption of lava. Let me go back to my Google Earth view maybe for that. So we just had this eruption of lava onto the surface on December 18th. And by adding this lava to the surface, now this is cooled, or largely cooled and solidified into basalt. This lava is a very dense material. And so just the gravitational loading of this lava onto the surface is exerting some stress as well. So we've introduced stress into different areas. We took magma from the subsurface, it erupted at the surface as lava. That lava flowed across the landscape, is now cooling and solidifying into solid rock. And so that exerts a stress on the area. Um, remember all the events we had leading up to November 10th and then even beyond as magma was moving through the subsurface. So just the propagation of magma in the subsurface generates fractures, and that's another stress. Then you have the heat of the magma chamber and that thermal expansion. That's yet another stress that is exerted on the rocks. We've been looking at the magma chamber over the last few weeks with the GPS measurements, especially inflating and rising. And so that's another stress, just that upward movement of the magma chamber. And then we might be seeing in some places where this old dike was that went down towards Grindavik, we might be having parts of the magma in the subsurface that's cooling and contracting. And that still also generates some amount of stress. And so when we talk about those earthquakes that we saw yesterday over here, the 4.3 and the 3.5, and now the smaller aftershocks that have occurred in that region, when we talk about all these stresses in the region, those are some of the factors that come into play. So I wanted to spend a minute there just explaining those in a little bit more detail because I think it sounded kind of like a vague geologist blanket statement, and I've seen it in some of the Iceland news stories as well with this, with respect especially to these two quakes and the quake swarm that's been taking place over the last 2 days off to the east here. Well, it's just in response to stress and tensile stress in the area. Well, those are some of the factors that come into play, and so the rocks in the whole peninsula are experiencing a lot of different forces or stresses on them as a result of all this change and everything that's gone on there. So hopefully that makes sense a little bit. Um, let's look real quick at a couple other things I've got prepared for you. The GPS data, we'll start with the main one we've looked at, which is the Svartsengi GPS station, the one by the power plant. So again, if you're new to the graphs, we're looking at mainly the bottom one here, which shows uplift. So when the little red dots trend upwards, that means the ground is rising. Around November 10th, we saw the ground actually drop because some of the magma that was keeping the land up and buoyant, that magma moved off to the east. Since that time, we've seen the ground rise in that area. So you can see this little tick upwards in the system. And then on December 18th, when we had the eruption, you can see it dropped down a little bit as well. And then since that time, we've been focused on more or less the endpoints of this graph out here and noticing that even though we've had uplift occurring into New Year's over the last, I guess, week or so, it's definitely at a lower level, right? The uplift is not happening as rapidly. In fact, you could argue, and there's error bars in here, so it's there's some plus or minus here, but it's at least slowed for sure and potentially stalled a little bit as well, and that may continue for some time. We may have um, we may have this thing stall for a little bit, and presumably that corresponds to an increase in the pressure right now that the land can no longer rise. If more magma is being fed into or not more, but if constant magma is being fed into the system and the land can't rise anymore, now we're just building up pressure and we're waiting for enough pressure available in the magma to override the confining pressure of the overlying rocks. And that's where we get into things like just all the different variables in the rocks themselves. In this part of Iceland, we have a lot of different rocks. Even though the rock type is all the same, it's all basalt. We have basalts that erupted underneath glaciers that produce pillow lavas and pyroclastic eruptions of ash. We have stacked lava flows. Some lava flows might be thin and quite porous. Other lava flows can be very thick and more dense. And so there's all those variables, the density of the rock, the thickness, how fractured the rock is, all those are playing a role in determining how much pressurization can take place before the rocks above fail and that magma makes its way to the surface for some sort of eruption. So that's worth looking at. Um, And other than that, that was the only big things I saw. It is worthwhile to look at some of the other GPS stations in the area. We've been focusing on the one near the power plant because that's where we believe the magma chamber is, or the sill, the main magma body that's being fed um, by conduits from the subsurface. But if you look at some of the other stations, so this is the Eldvorp station, which is off to the west, a few kilometers west of the power plant. You can see it rise around November 10th, and a little bit more of an uptick during the last eruption. Well, that's the north-south plot, so that's just moving to the north. The east-west plot shows it moving downward, which would be to the west. And then you can see again that deflection there. But if we look at this one in terms of uplift, so looking at the last plot here, you can see that it's still trending upwards. And so what we may be seeing is that even though the area at the power plant, that it's no longer rising, the sill, the magma body, is pushing outwards laterally, mostly to the east and west, and that is still being compensated by uplift. And so there is uplift happening in other places, and it could be again related to rock strength. Maybe we have very dense rocks at the power plant site, and so it just can't rise anymore. Maybe, but for whatever reason, we're seeing uplift in other places, and so we're able to accommodate that magma influx by deforming some of the land in some of these other places. So I'll make sure I put a link to this page here, which has a lot of different stations. And if you click on any one of these graphs, any given station, you can see it bigger because they're all kind of small. Here's the one. Let's see. Here's what's another good one to look at. Where's the Thorbjorn one? I don't see it on here. Oh, here it is. Another one right here that shows, again, this one's still trending upwards. It's stalled maybe a little bit, but it's still has a little bit of an upward trend there. Let me make sure my little picture thing's out of the way. So very slight uptick in elevation, but pretty steady over this period since December 18th. So yeah, so we're definitely in just sort of a wait and see period. So let me turn to some of your questions. And I appreciate everyone who's jumped on today with me and joined me for the little live stream drone flight. If I appear a little less polished, it's because I think as humans, we don't multitask well, and I don't think I do as well. So trying to operate the drone and see what's happening and get it to where I want it to go and provide commentary at the same time is sometimes a little bit of a challenge for me. So appreciate you being patient with me. Okay, so for those of you that have donated to this, thank you very much. It's always appreciative. Again, always thanks to the good folks at Nature Eye for helping out here. Let's see, here's a question from Gary. Could it be possible that the recent earthquake in Japan is linked to events in Iceland? That's something I've heard from a couple of folks. No, we're completely different parts of the planet. It's totally different tectonic systems. It is true that stresses can be transmitted through Earth's crust over distances, but not that big of a distance. And so the unrest and earthquake activity in Iceland is not at all related to what's been happening in Japan and vice versa. So there's no real triggering mechanism there over those kind of distances. So good question, but no. Let's see. Let's see. Big Willie wants to know what my best guess is to when there might be another eruption. I had said earlier, maybe a week or so ago, that I thought the first 2 weeks of January. But that's just, I mean, I'm throwing ideas out there just like you good folks. Like, I'm looking at the data. When would it occur? I don't know. Remember that a lot of times, this is an important point too. A lot of times these magma intrusion events, so we definitely know we have magma moving into the subsurface. We had an eruption a few weeks ago. But a lot of these magma intrusion events end with no eruption. Magma just moves up towards the surface, can't quite overcome the strength of the rock above it, isn't quite pressurized with the gases and what it needs to break the rocks above, and that magma doesn't erupt. And so it stays there. It does start to cool slowly over time. And what you need is another pulse of magma or a surge of magma into the subsurface in order to trigger that. And I was actually just reading a paper. It has to do with Hawaii, but it's about magma surge into the upper mantle. And they talk a little bit here about, I can put a link to this as well. This is open source. I'm trying to find the part here. Let's see. But they talk basically about that, these pulses and surges of magma. That's common with volcanoes. So it's not like it's a constant supply of magma, like a conveyor belt or an elevator bringing that magma to the surface. It's a pulse of magma that rises, causes earthquakes and ground deformation, possibly produces an eruption, but not always. And then there's another surge that happens later, and sometimes those time components between surges can be quite long. Sometimes they're much closer. So that's maybe worth mentioning. So, but to answer the question, I can't remember who it was, Big Willie. I guess I'll stick with that first couple weeks of January, possibly. But I'm not going to be bummed out if. Well, I would be a little bummed out if there wasn't an eruption. Of course, we don't want an eruption that affects Grindavik, but I think all volcano lovers would like to see some sort of eruption that's in a safe, non-impactful area. But if nothing happens in the next 2 weeks, like, I won't be surprised. So time will tell. But I think most scientists that have been looking at this agree it's likely to erupt. And I would say within the next few weeks would be what I would say. So, okay, let's do maybe one more here. We'll kind of keep this short for today. Rachel wants to know if the berm that goes around the town is constructed out of lava rocks. Yeah, what they'll do is they'll just quarry. I don't know exactly where their source is, but they'll quarry. They've got this one right here. So if you look just to the north of where they planned the berm, right near the highway here, they've been quarrying this hill, which is made out of, probably just based on the color and the topographic feature there, this reddish material is likely pyroclastic material, ashes, cinders, loose aggregate that they can scoop up in with trucks and then put into place with bulldozers and other equipment. And so they are using the same material that they have there locally to form that wall. So awesome. Well, we have to cut it short a little bit today because Nature Eye set up the live stream and they need to sign off soon to get to some other stuff. And so I will be sure to go through all your questions on the live chat. And maybe what I'll do tomorrow or Saturday, if there's not a lot going on, I'll do a Q&A where I address some of your questions. So if I'm not getting to your question today, please know that I will read it and I will compile a bunch of those questions like I've done previously and then address those in a separate Q&A. So thanks for everyone for joining me today, whether that was morning or afternoon or whatever time you're in. Appreciate you jumping on this live stream and enjoying the drone flight with Nature Eye. Remember, if you put my name in, Shawn, S-H-A-W-N, if you go to Nature Eye, you get 10% off any drone flight you want to do at any of their locations there. So, and I'll make sure I put a link to all those things in the video description. So sorry to cut it short today, team, but appreciate all of you for joining us. Appreciate our learning community that we're all learning and growing together, and have a great day. Enjoy. Take care.